Hello everyone, welcome back to my YouTube channel. In this video, I want to continue to solve a question from Past Paper EJU Mathematics 2022, second session, course 2, question number 1 from section 2. So this is basically the third question from this past paper. If you want to watch the solution from the other problem on this paper, you can check link on the description box below. And you can also check my EJU playlist if you want to find the solution from the other past paper. And hopefully that playlist will help you for your EJU preparation. Before I start, if you like this video, don't forget to hit the like button, share this video to your friend, and subscribe my YouTube channel. In this question, we have a sequence A1, A2, and so on, such that the n term is given by blah blah blah. So I have a sequence where the n term is given by 4n squared plus 5n minus 6. For D, E, H, and I, in question 1, choose the correct answer from among 0 until 9 at the end of the question, and for the other box, enter the correct number. So I will give a highlighter on D, E, H, I first. D, E, H, and I. So for D, E, H, and I, we need to see the correct answer among these choices. Okay, we are to find the numbers n such that an is multiple of 5. Also, we are to find the values of a of n or an in those cases. First, an can be vectorized as blah blah blah. So first thing first, we need to factorize a of n. Since this is a quadratic equation, I think it is easy for you to vectorize it. We can vectorize it becomes 4n and n, and then minus 2 plus 3. Let me check. Negative 8 plus 3. Oh, I think the sign is flip like this. Plus 8 minus 3 equals to plus 5. Yeah, so this is my vectorization. So a here is 2, and then b and c is 4 and 3. So a of n is equals to n plus 2 for n minus 3. We already get the answer for a, b, and c. Hence, if an is multiple of 5, then either n plus 2 or 4n minus 3 is multiple of 5. Makes sense, yeah? You have the product of the first and the second factor. Since the number is a multiple of 5, that means either the first one or the second one should be multiple of 5. I think this statement makes sense. In the case when n plus 2 is a multiple of 5, n can be expressed as blah blah blah, where k is an integer. They tells us that n plus 2 is a multiple of 5. So I can write down n plus 2 is equals to 5k. 5 times a number or an integer. That means n is equals to 5k minus 2. So for D, we need to find the answer from the choices below. 5k minus 2 is, 5k minus 2 is number 1. So I think the correct answer for D is number 1. Then an can be expressed using k as blah blah blah. After I know n is equals to 5k minus 2, I can substitute it into this quadratic equation. Or of course, I can also substitute it into this form. So up to you. You want to substitute it into the first function or to the second one. I think the answer should be the same. But for me, it is easier to substitute it into this one. So an is equals to 4n plus 3 times n minus 2. Oh, 4n minus 3, yeah? Times n plus 2. If I substitute n by using 5k minus 2, then I will obtain 4 times n is 5k minus 2, minus 3, times n, 5k minus 2, plus 2. You can cancel out minus n plus 2 here. And then if you simplify the expression, you will obtain 20k minus 8 minus 3. Negative 8 minus 3, you got negative 11 times 5k. Let me see the choices below. Oh, I think we need to distribute the k, yeah? If I distribute the k into the bracket, then I will obtain 100k squared minus 11k. So my answer for letter E is 100k squared minus 11k. Oh no, wait a minute, we just distribute the k, yeah? So instead of 100 here, it should be 20. My bad, this is 20k squared. So 5 open bracket 20k squared minus 11k. The answer is number 5. 5 open bracket 20k squared minus 11k. So the answer for letter E is number 5. Next, in the case that bn minus c, b is 4 and then c is 3, is a multiple of 5, we have blah blah blah. If you see here, this is 4n minus 3. C is equals to 3, yeah? 4n minus 3 is equals to blah 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 times j, where j is an integer. Same with the previous question. Since 4n minus 3 is a multiple of 5, that means 4n minus 3 must be equals to 5 times an integer. So f here, I'm pretty sure the answer is 5. This equality can be transformed as blah blah blah. Next, I want to transform this equation into blah blah blah. Let me write down the equation first. I have 4n minus 3 is equals to 5j. That means if I see this form, I need to rearrange the equation first. As you can see here, you have f here. F is 5 times negative j. So I think 5j here is should be moved to the left hand side. Then I will obtain 4n minus 3 minus 5j is equals to 0. And then since I factorize f here, f is 5, you can imagine 5 times n, you should have 5n, but in your equation you only have 4n. That means I can add both sides by n. I will add 1n here and 1n there. So that I will obtain 5n minus 5j equals to 3 plus n. I will move negative 3 to the other side. That means if I factorize 5, I will obtain n minus j equals to n plus 3. So n plus 3 is equals to 5, open bracket, n minus j. So letter G here is 3. This is 3. Thus, n can be expressed as blah blah blah. If you see here, n minus j is an integer. Of course, I can change n minus j here into a new integer. In this question, they already said that k is an integer. So I think n minus j here can be substituted or changed into k. So I have n plus 3 equals to 5k. That means n is equals to 5k minus 3. For h here, we need to see the answer from the choices below. 5k minus 3 is 2. So h is equals to number 2. From this using k, we have a n equals to blah blah blah. Once I got n equals to 5k minus 3, once again they ask us to find an. My an is this one or this one. Now I will try to use the first equation to find the expression for an. An is equals to 4n squared plus 5n minus 3. Let me check once again. 4n squared plus 5n minus 6. And then I will substitute n into 5k minus 3. Then I got an is equals to 4. 5k minus 3 squared plus 5k minus 3, negative 6. By simplifying this quadratic equation, I think we will obtain the correct answer for letter I. I will expand it first. 25k squared minus 30k plus 9 plus 25k minus 15 minus 6. And then let us distribute 4 into the bracket. Then I will get 100k squared minus 120k plus 36 plus 25 minus 21. Then I will get 100k squared. Oh, wait a minute, this is 25k, yeah? I forgot to put the k. 120 plus 25, we have negative 95k. And then 36 minus 21, we have 15. If I factorize 5, then I will obtain 20k squared minus 19k plus 3. I think this is the correct answer for letter I. So the answer is 5 open bracket 20k squared minus 19k plus 3. So letter I is number 9. Okay, let's move to the last question. For L and M, choose the correct answer. I will take a note with my highlighter. L and M, we need to see the answer from the choices below. But for J and K, we should enter the correct number. The question is, among the first 20 terms of A, the number of terms which are multiple of 5 is blah blah blah. I already know that an is equals to either this one or this one. This is my expression for an. Let me write down first, yeah. An is either the first one, 5 open bracket 20k square minus 11k, either this one or this one. This is the second one. So I can write down an like this. For the first one, the value of n is equals to 5k minus 2. So for the first one, n is equals to 5k minus 2. And then for the second one, n is equals to 5k minus 3. N equals to 5k minus 3. I need to find the number of terms which satisfy the value of n. My n is 20. So how many value of k that we can obtain for the first 20 terms of n, So if I substitute n by 20 here, I will get 20 is equals to 5k minus 2, then k is equals to 4 point blah blah blah. That means before, or maybe I should say, for the first 20 terms of a, there are 4 terms which is multiple of 5. So there are 4 terms for the first equation here that is multiple of 5. Because I got k equals to 4 point blah blah blah. That means there is 4 value of k that will give this as a multiple of 5. And then for the second function, we can do the same thing. Since n is 20, that means 20 is equals to 5k minus 3. Then you will get k is equals to 4 point blah blah blah. So I can conclude that for the first equation here, there are 4 terms which are multiples of 5. And then for the second function here, there are also 4 terms which are multiple of 5. So the number of terms which are multiple of 5 is 8. 4 plus 4. Then you will have, or you will get 8. So J here is 8. Also, the sum S of them is blah blah blah. We want to find the sum of them. Since k is 1 until 4, so letter k here is 4. So letter k here is 4. Then L is the sum of these two expressions. So if I write it down, I will have S equals to sum from k equals to 1 until 4 of L. L is the sum of these two functions. I will obtain 5 20k square minus 11k plus 5 20k square minus 19k plus 3. If you simplify it, since they both have common vector of 5, I can factorize 5. Then I will obtain 20k square minus 11k plus 20k square minus 19k plus 3. So my final answer is k equals to 1 until 4, 5, 40k square minus 30k plus 3. So this is the expression for letter L. 40k square negative 30k plus 3 times 5. So I think L is number 6. And then the sum for k equals to 1 until k equals to 4 of this expression is equals to blah blah blah. Since we need to add only 4 terms, I think we can do it manually. If I substitute k by 1, then I will obtain 40 minus 30 plus 3. 40 minus 30, 10, 10 plus 3, 13, 13 times 5. Or I will write down 5 outside the bracket. 13 plus, if you substitute k by 2, you will get 40 times 4, 160, yeah? Minus 2 times 30, 60, plus 3. Then you will get 103 for the second terms. And then for the third terms, we substitute k by 3. 3 square is 9. 9 times 40 is 360 minus 270 plus 3. Then you will get 93, I think. And then for the last one, we substitute k by 4. 16 times 40, 640 minus 120 plus 3. If you calculate it, you will obtain 523. If you add all of them and then times it by 5, I think we will get the final answer. If you calculate it, then your final answer is... Oops, wait a minute, I think I miscalculate something. Let me check for a while. This one is incorrect, yeah. Instead of 93, I think I miscalculate this one. This one should be 273. I miscalculate this one. This one is 273. If you add all of them and then you times it by 5, then your final answer is 4,560. So your final answer is number 2. This is the last question on this video. Thank you for watching this video till the end. I hope I can see you guys on my next video. Bye bye.